Now let's talk about, as an investigator, what the arson scene might look like, what signs are we looking for, and how we would collect evidence from it. These are very complex and difficult scenes. There's a lot of destruction there, and it can be very easy to misinterpret information and evidence. So it's important not to make assumptions. It's really important to have a established, experienced arson investigator who has years of experience that really helps with analyzing this. It can be, on paper, we can make it sound simplistic. It's actually fairly complex. Things that complicate this is that often an arsonist will have planned in advance and have thought about how to removing evidence, and they're not going to be around during the fire, right? Often they can set it up so that they can trigger the fire and then not be there when the fire is taking place, so you don't have a nearby suspect. And of course, fire is very destructive, so our physical evidence may not be there, may be destroyed in the process. So what we are looking to do as criminalists, as people on scene, would be looking for chemical composition that suggests, from the scene, that would suggest that I had something that ignited it. So we're going to reconstruct how the fire actually started and took place, and if it was done intentionally, and we will try to use some evidence of chemical composition to tell us if there was accelerants around. All right, so when you arrive on the scene, our first job, of course, is safety. Fires are very dangerous. Safety becomes paramount. Once it's safe to enter the scene, really trying to minimize damage and loss of evidence, and that's going to be particularly difficult in this case. They're already partially destroyed, and they're going to, if they're warm, they may continue to be burning and smoldering. Also, accelerants are going to be evaporating and disappearing with every moment that goes by. Most of our arsons are going to be identified as arson because they usually are started with some kind of what we'll call accelerant. In other words, putting gasoline on a fire or lighter fluid, or using something to begin the fire and make sure it gets hot enough that that fire will be sustained and the entire place will be engulfed. It doesn't help if an arsonist starts a small fire and it just burns itself out. So they typically use accelerants, and that's our key to identifying that it's arson, is looking for those petroleum-based accelerants. And we're going to find our best source of evidence at the fire's origin. So we want to try to figure out where the fire started, reconstruct it, what was the origin of the fire, and then look at that area for debris that might have accelerant residue, for evidence of an ignition device or something like that. So we would be looking for evidence of separate and unconnected fires. Oftentimes, in order to ensure that the whole place goes down, an arsonist will not just start one fire, but start multiple fires in different areas. And if they're not connected, it suggests that there was different fires started. In other words, an electrical fire is only going to generally start in one place, whereas arson would be multiple. There can be other things that could create separate sites of a fire, though. You have to be careful. Streamers, so in other words, if you have a trail of gasoline, you can see a burn trail that's sort of connecting one fire to another area. A irregularly shaped pattern of burn on the floor. When you pour the accelerant, you're going to have splash patterns, and that will be also replicated in the burn pattern. So that's suggestive of an accelerant. Also, severe burning at that site. So where the accelerant is, it tends to burn at a higher temperature and get a deeper amount of char, might indicate that there's been a flammable liquid. Fire tends to move upwards. It starts low and it tends to move upwards. As it gets hotter, that creates that chain reaction at higher sites, and since the heat is going up. So we're going to look at the low areas generally for the origin sites. We would be looking for an ignition device. That would be like great evidence that it was set. So it might be a match. Probably wouldn't survive the fire, but a match would be very common. Cigarettes, burning cigarettes. Again, then there might be some residue left from the filters that they didn't completely burn. Firearms, the metal of the firearms would be left behind. Ammunition, if I can find, again, some kind of like gun shells or something. A mechanical match striker or electric sparking devices. So, these are the variety of different lighters or the butane lighters that have the trigger on them. Any kind of sort of electrical or mechanical ones that operate off of friction or ones that operate off of clicking a button or something like that. And then Molotov cocktails, which are glass containers, jars, bottles, where there's been some kind of accelerant in it that's been started on fire, and usually has a rag that gets started on fire that and then is thrown so that it doesn't actually catch fire in great detail till after it's left the arsonist's hands. So one of the things we're going to look for is this flashover. Flashover is a natural process that happens that might mimic the look of arson. And so we have to be careful and know about it and know that it can make things appear to be arson when they're really not. And what happens is when you begin having, as that fire gets hotter and hotter, you may reach a temperature where everything combustible, all the materials that could catch on fire, reach ignition temperature and then simultaneously all engulf in fire. When you're watching videos of this, and you can do a video, do a video search for flashover video, and fire departments will often make these as a public safety announcement. And you can see that all of a sudden the fire drastically goes off and gets much bigger. And when that happens, you might get parts that fly out and then start a new fire, so it might look like separate fires. You can get some unusual burn patterns and get a particularly deep area of char, which might look like there was accelerant there. So we get these illusions that we have these irregular patterns that might be mistaken for arson, when in fact they're just a natural byproduct of how fire is a chain reaction. So we would be looking for both of these, deep depth of char, this V-shaped burn pattern on walls as it kind of expands up and out, and a low intense burn area. These are signs that it could be either flashover or arson. And again, an experienced investigator is needed to really differentiate those. So what do? You arrive on the scene. If you're not a fire investigator, but you're collecting evidence, we're going to be trying to look for debris from the site of origin. Again, we're trying to sort of track where is the most intense. Can we observe the trail patterns of where it looks like the fire started? And then ash, soot, any porous materials, fabric kind of materials, and it would be stored in an airtight container. Again, probably if there was accelerant like gasoline, if I leave it in a package that's not airtight, it might evaporate and be gone by the time it gets to the lab. So a primary importance on this is airtight. So usually they use metal paint cans. They're not paint cans in the sense that they never had paint in them, but they're look identical to paint cans. So these are empty, clean metal cans that can be sealed on top. And you need to make sure to leave an airspace. These are going to be volatile things. They're going to build up pressure inside. You don't want it to explode and destroy all the evidence and hurt somebody. So you can't fill them up to the rim. You have to leave a probably halfway empty and have what they call a headspace. That's an area where gases can build up, but not to a pressure that they destroy the container. Never use plastic containers. Petroleum-based accelerants can dissolve plastics, right? If you pour some of these later fluid on plastic, sometimes it melts it. So plastic is not an acceptable packaging material. It's also important to have a substrate. So substrate would mean a sample that was not from the site of origin that might tell me about some of the similar materials that were there, and I can kind of get a baseline of what chemicals are in that house that wouldn't be from the accelerant. So sofas, a lot of times the foam in the cushions of a sofa have a lot of these same petroleum-based products. An awful lot of our fabrics. Sometimes the coatings on laminated wood floor have these same petroleum products. So we need to kind of know, was this an accelerant that was added or was it already there? So we need to take samples not from the origin site to have for comparison. Some of these could be used. There are two sort of screening devices we might be able to use. One is called a sniffer. It's sort of kind of like a breathalyzer, fuel cell sensor, similar to that. It's a device that can be brought around and it can sort of detect if there's vapors. Also, there are specially trained dogs that are used for looking for these vapors and sort of hone in on this is where you need to collect evidence from. Once we get to the lab, we need to recover that. So you get this big pile of debris and burnt stuff. And so how do we recover stuff from that? So there are two common ways we're going to use. One is called the headspace recovery. One is called vapor concentration. In the headspace recovery, that, remember, there's that area of air that we left inside the paint can. So you would use a syringe, poke it through the top of the paint can, and take some of that gas out. And then we could do a gas chromatography analysis on that. So headspace recovery is one. If there's not a lot of stuff there, if that doesn't show anything, another one that could be used is something called the vapor concentration technique. And in this way, a charcoal strip, so a piece of charcoal paper is placed inside that headspace. And what it does, it sort of absorbs all of those vapors into it and concentrates them and makes it a stronger signal. Then that piece of charcoal would be taken and put into solvent to recover those things, and then that would be sent through gas chromatography. So two different ways of kind of collecting those accelerants out of the debris to look for the things that we're specifically looking for. This is an example of that vapor concentration where there's sort of a hanging from the ceiling of the lid is this charcoal strip that's absorbing things. It would be heated up to kind of help the debris evaporate some of those accelerants and then concentrate it on there, and then this could be taken and the strip would be removed from here and then used and extract out the vapors and analyze.